This is the revision in physics for week 3 and 4 in semester 1. In this revision, we're going to study the types of forces and classify them as contact forces and acting at a distance. And going to study the type of contact forces and type of forces acting at a distance. So like we said, we'll study the types of contact forces, the types of forces acting from a distance, and force representation diagram, how we represent forces on a diagram. Types of contact forces, Hamad read.
Friction, normal reaction, tension.
Tension. So these are the three types of contact forces. I know we have a lot, but in this chapter we're going to study the contact forces as friction, normal reaction, and tension. Friction force, the first force. By definition, it is a resistive force that is opposite to the force of motion. So as you can see with figure 1, the first figure, we have the motion is to the right, so the friction will be to the left. And the friction is in contact between the box or the object and the ground. So this is a resistive force done by the ground on the object and is opposite to the motion. So that's how we represent the friction is always opposite to the motion, it's a resistive force. In the second figure, in figure 2, we can see that it also helps us in moving. So sometimes also the force is resistive, but it also can happen in other situations like moving. So when you walk down on the ground or on the way, whatever, it helps you in moving and walking. This is friction. So it's a contact force. Second force B, Dana, read please.
Normal reaction. Any force coming from the surface and acting at a right angle to the surface is called the normal force.
So this is a normal force or normal reaction. It's always opposite or perpendicular to the surface of contact. So you have two situations here. The first situation or second situation. Here we have the first case. We have an object placed on the horizontal ground. So the normal reaction is upward, is directed upward. This is the reaction done by the ground on the object. The second situation, you have an inclined plane. Okay, the object is placed on an inclined plane. The reaction is coming from where the object is placed on the plane. So it's always perpendicular, making angle 90 with the surface. This is the normal reaction, a contact force. Two objects touching each other, contact force. Selena, tension.
The tension force is the force that is transmitted through a string, rope, cable, or wire when it is pulled tight by forces acting from opposite ends.
So, the tension is type of a resistive force opposite to the force acting on the string. So in this example, you have the ball is making a force downward by the action of the gravity or the weight. So the string will also do another force which is upward. Yes, the tension. This is the tension. So it's always along the direction of the string, rope, or spring, whatever. And it's always opposite to the motion or the pulling force. This is a contact force because the string and the ball or the object are in contact with each other. We finished on the forces acting, contact forces. Now we study the forces acting at a distance. We have three types. Allah, can you read them, please?
Forces acting at a distance. Magnetic force, electric force, gravitational force, weight.
Wait, so we have three types of forces acting at distance: magnetic, electric, and gravitational force. Allah, why they are named like this, acting at a distance? Yes, because the bodies which are acting on each other, they are not in contact. Unlike contact forces, two bodies are in contact with each other. The first one is the magnetic force. The magnetic force is the force done by a magnet. So you should have a magnet. Here we have two situations. The first one is repulsion. You have repulsion force. The second one is you have attraction force. The repulsion force, as you can see, the object, let's say it's an iron ball, the object is moving away from the magnet. Okay? So the force acting on the ball is a repulsion force and is moving in this direction. So this is the force done by the magnet which causes repulsion. Okay? Fine. And the other situation, attraction. Okay? With attraction, suppose you have like an iron ball or whatever, the magnet is attracting the iron ball towards it. So this is the magnetic force exerted on the ball. So in the first situation, we can have like two magnets, okay, opposing each other. We have like north pole facing north pole, or south pole facing south pole. So opposite poles, we can cause repulsion. The second situation, we could have like an iron ball. Okay, we are approaching a magnet towards it, so the magnet is attracting the ball towards it. So we could have a repulsion force or attraction force. And Ali, why it is acting at a distance? Why this force, magnetic force, acting at a distance?
Because we are not going to make contact to
The two bodies are not in contact. Okay, we can first figure if I have like two magnets, they are away from each other, or in second figure the magnet and the iron ball are also away from each other. Even though they are away from each other, there is a force acting at a distance. Electric force is similar to the magnetic force, but it is the force of attraction between two opposite electric charges, or the force of repulsion between two identical electrical charges. So if you have like a positive electric charge and a negative electric charge, you will have attraction, like we have seen in the previous slide. Or you have two identical electrical charges, positive and positive, negative and negative, you will have repulsion. So we draw it and represent it as we did with magnetic force, same representation, but different naming, magnetic, electric. Okay? Gravitational force, or the weight. Badia, read please.
Weight is the force generated by the gravitational attraction of the Earth on any object. It's always directed downwards.
So suppose you have like a box placed on this table. The point of application of the weight is always in the middle or the center of gravity, and it's always directed downward. So this is the weight. It is the gravitational force, the force of attraction by the Earth on the object. Okay? Let's study this example. The diagram below shows a box attached to a rope. The box is placed on an inclined plane. A. Give the names of the forces acting on the box. Muhammad Saleh, can you name one force acting on this box? No. Give the name of a force. Tension, weight. Okay. The first force we have weight. Ala. Tension. Good. Selena. Normal reaction. Do we have other forces? Do we still have other forces? No. What, Selena? Is it moving? It's not moving. You will always have friction when there's movement, there's motion. So we have three forces. We have the weight, normal reaction, and tension. Good. Selena, let's classify them. The weight. What is the type at a distance? Good. Tension, contact, normal, contact. How we represent them? So we have the weight downwards. You have the normal reaction. It starts from the point where it's touching the ground. This is the normal reaction. And this is the tension when the rope is touching the box. This is the tension. Okay? Now, suppose we cut the rope. If I cut the rope and the object starts sliding downward, yes, you will have a new force with friction. Tension will stop existing. There will be no more tension because you cut the rope, but you have friction. If it's sliding downward, if it was sliding downward, the friction will be upward in the opposite direction. Okay?